Imagine a world before memory, a world wrapped in vapor, where light could only guess at what waited beneath. From that haze, oceans began to gather. They fell from the sky for millions of years, drop by drop, until the planet's heartbeat slowed into blue. Every ripple since then has been a kind of recollection, each molecule once touching a mountain, a shell, a cell, a dream. The sea remembers everything, even the silence before life began to hum. As you listen, you might feel your breath matching that old rhythm. In like the tide, out like the drift. We will move through time together, calmly, through waters that held the first sparks of motion and the last reflections of vanished suns. You're listening to Science in Stillness, where knowledge whispers to sleep. Tonight's story is about ancient oceans, and the quiet truth that ancient oceans cradle the memory of every world before ours. Now, let the waves steady your pulse, and the first chapter begin, not with sound, but with stillness. Before there were continents, there was heat. The young Earth turned beneath a newborn sun, its crust soft as unfired clay. Volcanoes stitched fire into the sky, and the air shimmered with steam. Into this brightness came ice, ancient, silent travelers of the outer solar system, drifting inward. Comets dusted with frozen water and carbon shattered against the molten plains. Each impact released a sigh of vapor that rose, cooled, and fell again. Rain began, not for hours or seasons, but for tens of millions of years. It was the longest rainfall the planet would ever know. Drop by drop, the steam condensed, whispering down onto lava until the glow dulled and the first puddles formed. These puddles joined into pools, the pools into basins, and soon the world was wrapped in water, a skin of blue surrounding a heart of stone. Scientists studying isotopes in ancient zircon crystals, tiny minerals older than almost any rock, have found traces of this first condensation. They tell us that liquid water existed 4.3 billion years ago, only a few 100 million years after Earth's birth. Imagine it. An ocean beneath an orange sky, its surface veiled in mist, its depths warmed by the planet's inner fire. In those early seas, chemistry found room to wander. The ocean was not yet the soft salt water we know. It was thick with dissolved minerals, metallic ions, and carbon compounds. Every molecule moved in slow choreography, nudged by lightning and ultraviolet light. From that restless mixture, the simplest patterns of life would one day unfold. Meanwhile, the planet's crust cooled and fractured, shaping the first basins, the low places where gravity gathered water into permanence. Waves began to exist, faint tremors across the newborn sea. There were no beaches yet, no shores to define here and there, and only the endless exchange of vapor and rain, sky and surface, the earth breathing through water. This was the planet's first memory, movement held within liquid, and in that movement lay the promise of remembering, a hint that water could carry stories without words. Every future ocean, from the shallow lagoons of the Ediacaran to the deep currents of today, would inherit this memory. As the nights lengthened and the storms thinned, the seas settled into a reflective calm. The sun's rays, once scattered by vapor, began to reach the surface. Light touched water for the first time, and the planet brightened, a quiet awakening. Some researchers propose that the salt of today's ocean still carries a trace of those first minerals, relics of ancient weathering and volcanic breath. The sodium and chlorine ions drifting now between waves were once released from basaltic stone during those primeval rains. To taste seawater, then, is to sip the oldest memory of Earth itself. The hypothesis begins to take shape that oceans, from their very birth, have been the planet's archive. They hold in suspension the chemistry of creation, the whispers of every eruption, every cooling crust, every fallen comet. When we look upon the sea today, we look into a record that never stops writing itself, a memory written not in ink, but in ions. As night deepens around this thought, imagine yourself floating above that ancient ocean. There is no life yet to disturb the surface, no sound but the wind. Beneath you, heat flows upward through thin crust, tracing bright seams across the dark. Above, clouds shimmer with lightning, silent from this distance. The air smells of metal and rain. The world is beginning to dream. From this dream will rise all things: coral, whales, us. But for now, the planet sleeps within its first lullaby, the slow, steady rhythm of falling rain upon an endless sea. The rain had ended, but the world was still warm beneath its new ocean. Steam lingered like breath on a window pane. Each droplet that had fallen from the sky carried with it a trace of the rocks it touched. Fragments of magnesium, sodium, calcium, iron. When these minerals met the cooling seas, they dissolved quietly, threading the water with invisible flavor. Bit by bit, the first brine was born. It was not yet the gentle blue of today's ocean. It shimmered with green and bronze, faintly acidic, dense with dissolved stone. If one could have reached a hand into it, the liquid would have felt heavier than expected, its texture more alive. Scientists call this the primordial soup, but it was less a broth and more a slow, glowing tide of possibility. Chemistry learning to listen to itself. In this ancient laboratory, carbon dioxide from volcanoes bubbled through the water. Lightning stitched the sky, breaking molecules apart and sewing them into new forms. Simple compounds, amino acids, sugars, lipids, drifted through the waves. They collided and separated, again and again, until some began to linger together longer than chance alone would allow. One can picture these early unions like sand grains finding rhythm in wind, temporary yet foreshadowing pattern. Over vast stretches of time, those patterns deepened. Bubbles formed, burst, and formed again. Thin films of molecules folded upon themselves, creating fragile boundaries, the first hints of a cell's membrane. Inside those tiny envelopes, the ocean's chemistry found focus. Meanwhile, minerals precipitated from the warm water onto the seafloor, forming clays that acted as natural scaffolds. These clays, layered like pages, trapped small molecules in their folds and pressed them into tighter association. In laboratory recreations, scientists have shown that such mineral surfaces can indeed coax organic molecules into linking, a first whisper toward replication, toward life. Thus, even before biology existed, the ocean practiced memory. Each reaction carried a trace of the one before. The water learned, in its own molecular way, how to hold a pattern long enough for something new to emerge. The ocean was not only a cradle, it was a mind in liquid form, rehearsing complexity. If you could float above that ancient sea, you would see no sign of this invisible drama. Only a calm expanse reflecting the copper glow of a young sun. Beneath, however, every drop was a theater of transformation. The chemistry of calm, the slow patience of ions and atoms meeting, parting, and rejoining, created the foundation for everything that would one day breathe, drift, or think. Even now, the same reactions continue. Every living cell still carries seawater in miniature, a salty memory of those first reactions sealed inside. Our blood, nearly identical in salinity to ancient oceans, is a moving testimony that the chemistry of calm never ended. It only migrated inward, into us. In the soft silence of that realization, the hypothesis deepens that water does not merely host life, it becomes it. Each molecule, drifting from comet to cloud to sea to cell, writes a continuous story of transformation. The same hydrogen that once steamed from volcanic vents now circulates in our veins. The same oxygen once split by sunlight now fuels our breath. So when we inhale, we join a chain older than rock, older than time as we measure it. We are the ocean remembering itself. By the time the ocean had learned its slow chemistry, the planet had quieted. The crust had thickened. The lightning softened its voice. In that relative peace, the molecules that had once danced alone began to stay together longer, sheltering in microscopic envelopes of lipid and clay. Some could copy fragments of themselves, a hesitant rehearsal of heredity. From this persistence, the first true cells emerged. They were small, fragile spheres, adrift in the dim shallows, each one a tiny experiment in endurance. Within their watery walls, reactions flowed in circles rather than lines. Metabolism, a heartbeat of chemistry. Scientists reading the isotopic record of ancient rocks, carbon signatures preserved in 3.5 billion-year-old formations, believe that such life appeared astonishingly early. Barely a billion years after the oceans formed, the sea was already alive. Imagine them. Mats of microbial life spreading over warm stones, each cell absorbing sunlight or the faint heat rising from hydrothermal vents. There were no predators, no competition, only diffusion and light. The air above was thin and tinted with methane. The ocean below glowed faintly green. The world's first photosynthesizers were at work. These cyanobacteria, literally blue-green builders, learned to use sunlight to separate hydrogen from water, releasing a byproduct no organism had ever known before: oxygen. At first, this gas dissolved quietly into the surrounding sea, oxidizing iron and turning the water a rusty red. Layer by layer, minerals settled onto the seafloor, forming banded iron formations that geologists still find today. Each stripe of iron and silica is a pulse of ancient breathing, the world's earliest record of metabolism written in stone. The process was slow but relentless. As the oceans filled with oxygen, the chemistry of the planet began to change. New minerals crystallized, new reactions became possible. The sky itself shifted hue from amber to a paler blue as oxygen met sunlight and formed the planet's protective ozone veil. The sea, too, transformed. What had once been greenish and opaque grew clearer, deeper, able to scatter light through greater distances. Under that new radiance, life diversified. The microbial mats thickened, forming vast carpets across continental shelves. Some sheets trapped sediments and grew upward into layered domes known as stromatolites, living rocks that still survive in a few quiet corners of Earth, such as Shark Bay in Western Australia. They are the last visible trace of the ocean's first architects, patient builders who turned sunlight into stone. The beauty of this moment lies in its quietness. No sudden explosion, no thunder of creation, only the gentle repetition of chemical memory refining itself. Each photon of sunlight that touched those early cells became an act of remembering, the ocean learning how to store light, how to breathe. And even now, every breath we take reenacts that discovery. The oxygen filling our lungs is a direct descendant of those ancient exhalations. When the tide slides in, when foam hisses against sand, the bubbles bursting on the surface carry the same rhythm: in out, the ancient pulse of photosynthesis, still unfolding after billions of years. Thus, the hypothesis strengthens. Oceans are not static mirrors of history, but living archives. They store light as life, sound as motion, memory as chemistry. The blue of the modern sea is not simply color. It is the visible ghost of those first breaths diffused through time. Some nights, when moonlight brushes the surface and the waves move as one, it is possible to imagine the ocean dreaming of those early days, of the first shimmer of green cells catching the dawn and turning it into air. In that dream, the planet found its voice, and the water learned to sing. Long before life learned to crawl or sing, the moon was closer. Its silver face filled the sky like a second sun, pulling at the young oceans with a force the modern tide can only remember faintly. Each day was shorter then, perhaps only 18 hours long, and the seas rose and fell in quickened breath, guided by that constant companion. In the hush between those early tides, the planet was learning rhythm. The moon's gravity tugged water toward it, lifting a bulge that moved endlessly around the globe. Friction between sea and seafloor slowed Earth's rotation little by little, lengthening the days, easing the heartbeat of time. What began as violent surges became a calm pulse, the first cosmic lullaby. Scientists reading tidal rhythmites, fossilized ripple marks laid down by ancient tides, have traced this slowing dance across billions of years. These stone records show that the moon's steady retreat, roughly 4 centimeters per year, has been sculpting the tempo of life itself. Each extra minute added to the day was a gift of quiet, a pause in which complexity could bloom. The moon, in essence, tuned the ocean to its orbit. It coaxed the water into memory, teaching it to rise and fall in cycles, to respond, to repeat. In those patterns, primitive life found stability. The first microbial mats that clung to the shore were rhythm-dependent, bathed alternately in light and shadow, salt and air. Tides fed them, drained them, and fed them again, imprinting the biology of time deep within their structure. Even now, within the circadian and lunar cycles of modern organisms, that ancient influence endures. Our sleep, our heartbeat, our cellular clocks still echo the tug of the moon on primordial tides. We are lunar creatures at the core, our chemistry synchronized to that distant orbit. The imagination can linger here, a world where night and day raced faster, the moon so near that its reflection shimmered across half the horizon. The tides would have towered, swirling around volcanic islands, flooding shallow plains before retreating in foaming haste. The noise would have been immense, yet also strangely steady, a sound like breathing, magnified. Over time, as the moon drifted outward, its pull softened. The seas grew quieter, their edges smoothing into the first coastlines. The newly oxygenated atmosphere began to settle into calm transparency, allowing starlight to shimmer upon the waves for the first time. In those reflections, the sea saw its twin in the sky, both bound by gravity, both keepers of memory. This relationship, born of physics, deepened into symbolism. The moon as mirror, the sea as soul. Every subsequent age of life, from trilobites to whales, would navigate by that bond. The phases of the moon governed spawning, migration, flowering. It became the metronome of existence. When we stand by the shore tonight, watching the tide rise in moonlight, we are witnessing the same choreography first practiced billions of years ago. The ocean still bows to its pale partner, still carries the memory of that first gravitational embrace. And within us too, that rhythm persists. In the saline tides of our blood, the subtle pull of sleep and waking, the drift of thought that comes and goes like waves under a lunar sky. The moon taught the water how to move, and in doing so, it taught the planet how to dream in cycles. The ocean remembers every lesson of that long courtship. Its surface may change with storms and ages, but beneath the noise, the rhythm remains pure. A reminder that even cosmic mechanics can be tender. For billions of years, the ocean's story had been one of chemistry and rhythm. Quiet, circular, patient. But as oxygen pooled into the water and spread through its layers, something new began to stir. The Ediacaran period, beginning around 635 million years ago, unfolded like a long exhale after the planet's great glaciations. Ice had once reached the equator. Now the seas softened, warming under a gentler sun. Out of this calm, the first complex bodies drifted into being. They were neither plants nor animals as we know them, but something in between, experiments in softness. Their forms were delicate, quilted discs, frond-like plumes, rippling ovals pressed gently into the sediment. The fossils they left behind looked like impressions in fine linen, as if the sea itself had been a loom. On the shallow sea floors of what is now Newfoundland, Namibia, and Australia, colonies of these creatures spread in slow choreography. Dickinsonia with its leaf-like segments, Sprigina with a hint of symmetry that would one day resemble a head, Charnia waving gently like underwater ferns. None had eyes, bones, or mouths. They absorbed nutrients directly through their surfaces, living on the boundary between matter and light. Scientists still debate what they truly were, ancestors of animals, or a lineage that branched off and vanished. But in their stillness lies the beauty of first design. They show that life can flourish without competition, that evolution sometimes whispers before it roars. The oxygen-rich oceans of this era glowed faintly blue-green under the new sky. Sunlight, refracted through clear water, painted the seafloor in gradients of turquoise and gold. In that slow illumination, the Ediacaran organisms expanded like dreams across the seabed. Their presence began to alter sediment, trapping particles, stabilizing currents, and laying the groundwork for ecosystems to come. Every trace of them, each soft imprint in ancient sandstone, is a page of memory kept by the sea. The ocean, for the first time, learned the shape of life large enough to be seen. It practiced complexity, symmetry, and grace. The stillness of those forms is deceptive. Beneath them, oxygen, minerals, and microbial films collaborated in silent engineering. When we run fingers across those fossil impressions today, we touch not only ancient creatures, but also the calm before abundance, a biological dawn suspended between eras. The Ediacaran hush is the planet's held breath, the pause before motion becomes momentum. If one could drift through those ancient waters, the scene would feel strangely serene. No predation, no haste, only soft bodies undulating with the current. Light falls through the surface like liquid silk, and on the floor below, translucent fronds sway as though listening. It was, perhaps, the most peaceful age life ever knew. And yet, within that peace, change gathered strength. Oxygen, the quiet sculptor, continued to accumulate. Enzymes became more efficient. Cells began to coordinate. Soon, the ocean's lullaby would quicken into a symphony, the Cambrian bloom waiting just beyond the horizon of time. The hypothesis breathes through this stillness, that the ocean does not rush its creations. It remembers, refines, repeats. From every calm period arises a new harmony, as though water itself dreams in cycles of rest and renewal. The Ediacaran world was one such dream, a soft rehearsal for the vibrant motion to come. So as you breathe now, slow and even, imagine that ancient hush surrounding you. The same oxygen you draw into your lungs once drifted through those primal seas, brushing against the surfaces of creatures who never knew eyes, never knew fear. Their stillness lingers in every tide pool, every quiet night by the shore. The ocean keeps that memory alive, a record written not in noise, but in gentleness. When the Ediacaran hush finally broke, it did so not with thunder, but with shimmer. Around 541 million years ago, the ocean awoke into the Cambrian period, and life began to write itself in shells. What had once been a landscape of soft impressions became a gallery of structure, symmetry, and light. Minerals long dissolved in the water, calcium, silica, phosphate, found new purpose in biology. Tiny creatures drew them into their bodies, crafting armor, scaffolds, and teeth of crystal and stone. The seas glimmered with their invention. Microscopic plankton drifted like dust motes, while trilobites, the iconic explorers of this age, crawled across the seabed, eyes shining with calcite lenses. This was not an explosion as much as a blossoming, a slow, radiant unfolding of possibility. Every niche became a question, and life's answer was variety. Worms burrowed through mud, aerating it. Sponges filtered the water, clarifying it. Predators emerged, testing the limits of motion. What had been a static garden now rippled with chase and retreat, feeding and being fed upon. Fossils from the Burgess Shale in Canada and Chengjiang in China preserve this bloom in exquisite detail. Delicate limbs, feathery gills, even traces of skin and eyes. They show that within a few tens of millions of years, the ocean's quiet had transformed into a kaleidoscope of movement. Scientists studying these strata often describe it as life-discovering geometry. Spirals, segments, lattices, and radial designs unfurling in a vast underwater ballet. The oxygen woven into the water during the Ediacaran now fueled greater complexity. Muscles thickened, nerves transmitted signals, eyes learned to find contrast. With sight came color, or at least its ancient analog, the play of light on shells, the shadows of motion, the shimmer of scales beneath a brightening sea. Yet even amid this flourishing, the calm remained at the heart of creation. The ocean's chemistry continued its patient work, circulating nutrients, balancing carbon and oxygen, recording every experiment and sediment. Each ripple of mud, each grain of limestone, became a ledger of living change. The Cambrian blooming reminds us that abundance, too, can be peaceful when seen from afar. Billions of tiny lives overlapping, each one brief, yet contributing to a pattern that feels eternal. The sea was not chaotic, but composed, its rhythms deepening. Evolution, in this sense, was an art of remembering. Every new form a variation on older themes, refined through repetition. If you could drift through that water, you would pass forests of sponge towers and reefs of early corals, glowing faintly in dim light. Schools of small arthropods scuttled below, leaving trails like calligraphy on sand. Above, gelatinous creatures rose and fell like lanterns. It was a quiet miracle, a world both alien and familiar, where the architecture of modern life was first drafted in coral ink. Some of those patterns survive unchanged. The shape of your own hand, the branching of fingers, the symmetry of bone, traces its ancestry to Cambrian limbs. Every vertebrate breath, every motion, echoes that first choreography of muscle and mineral. The ocean, in remembering, became the tutor of anatomy. So when we marvel at the beauty of coral or the shimmer of a fish, we are seeing ancient memory in motion, chemistry given form, persistence turned to art. The ocean still teaches through pattern, still shapes through patience. In the hush between tides, you can almost hear it. The echo of that first blooming, the whisper of shells being born in darkness. The sea carries those stories not as fossils alone, but as vibrations in every current, every wave, every breath. After the Cambrian bloom came structure, not just shells and limbs, but homes. The ocean, ever the quiet architect, began to build reefs. They were not yet the bright coral cathedrals we know, but intricate scaffolds raised by tiny architects, microbes, sponges, and early coral ancestors. In their patient work, the sea learned how to construct permanence out of fragility. The earliest reefs formed in the Ordovician and Silurian periods, roughly 470 million years ago. Microbial mats, layers of cyanobacteria and algae, trapped sediments and bound them into ridges. Sponges colonized these ridges, adding texture and strength. Then came corals, ancient relatives of the ones glowing in modern tropics. They secreted calcium carbonate, a mineral shell that could withstand waves. With time, these colonies grew upward toward the light, creating underwater mountains. Each reef was a slow conversation between chemistry and life. Minerals precipitated from seawater, layer by layer, guided by living membranes. The balance of ions, calcium, magnesium, carbonate, acted like a soft code, telling the ocean how to crystallize its memories. In cross-section, a fossil reef looks like a cathedral floor, layers of biological design recorded in stone. To swim through one of these reef cities of deep time would have felt like entering an alien metropolis. Towering sponges rose like chimneys, filtering water in a continuous breath. Corals fanned outward, catching sunlight. Crinoids, delicate stemmed creatures related to sea lilies, drifted in slow pirouettes. Each organism contributed to a community that transformed water into architecture. Paleontologists studying these reefs find evidence of complex ecological networks, early food webs that connected plankton, grazers, and scavengers. What began as solitary life had become social, interdependent. In this sense, the ocean was practicing memory again, collective rather than individual. Every organism relied on the rest, and in their shared stability lay survival. Reefs also changed the planet's chemistry. By trapping carbon dioxide within limestone, they cooled the climate, balancing the atmosphere in ways that allowed land to flourish. The air we breathe now carries the legacy of their slow construction. Each coral, though silent, helped write the conditions for future forests, for us. Even their deaths became foundations. When storms broke the outer walls, fragments fell to the seafloor, serving as seeds for new growth. Over time, layer built upon layer, not erasing what came before, but enfolding it. In this, reefs mirror memory itself, cumulative, gentle, resilient. If one listens to the modern ocean, that same pattern hums beneath the waves. Coral polyps extend their tiny arms, harvesting light from symbiotic algae, turning sunlight into stone. It is the same equation their ancestors solved 500 million years ago. Chemistry becoming shelter, life turning fragility into endurance. From the surface, the sea looks fluid, impermanent. But beneath lies a landscape of patience, where every generation adds a whisper to the architecture of eternity. The reefs of deep time remind us that even the smallest beings can sculpt the largest legacies. And so the hypothesis drifts onward. The ocean remembers not only what it contains, but what it builds. Its reefs are monuments to collaboration, proof that memory, when shared, becomes structure. If you close your eyes now, imagine descending through clear water into a world of pale blues and amber light. The current slows. The silence deepens. Columns of coral rise like pillars in a submerged temple. Tiny creatures flicker in and out of shadow, their movements tracing invisible music. This is the sea's cathedral, not of stone alone, but of time, patience, and remembrance. Each bubble that leaves your lips carries a message the reefs already know, that endurance is quiet, and beauty, when born of repetition, never fades. Beneath the serene cities of coral, another ocean existed, darker, hotter, older. It was the realm of underwater volcanoes, where the crust of the earth opened in long seams and released its hidden breath. From these fissures poured not fire, but water, superheated, mineral-rich, and full of secrets. These were the hydrothermal vents, the black smokers of deep time, and they may have been among the first homes of life. The mid-ocean ridges, those vast mountain chains that circle the planet's floor, are places where the crust continually renews itself. As molten rock rises and cools, seawater seeps into cracks, becomes heated, and emerges again in shimmering plumes. When that scalding fluid meets cold seawater, metals precipitate out, iron, copper, zinc, creating clouds of black particles that drift upward like ink in silence. Around these vents, life gathers even now, blooming without sunlight. Imagine it. In the utter darkness, 2 kilometers below the surface, towers of mineral crust hiss softly. The water is near boiling, yet only meters away, it is freezing. Between those extremes lies a narrow band of life, worms, crabs, bacteria, sustained by chemistry instead of light. They feed on hydrogen sulfide, the gas that smells faintly of brimstone, using it as fuel to build sugars and tissues. This process, chemosynthesis, is photosynthesis's shadow twin, proof that life's hunger for energy finds many languages. Scientists believe such ecosystems may have been present since the dawn of life, 4 billion years ago. In the mineral chimneys of ancient vents, they find microscopic fossils, filaments and tubes of iron oxide that once housed bacteria. The structures look like delicate reeds turned to stone, each one a memory of an organism that thrived where no light ever reached. If the surface reefs were the ocean's cathedrals, then these vent fields were its forges, places where matter was remade. Metal met life, and both were transformed. The chemical gradients between hot and cold water acted like natural batteries, generating the energy necessary for complex molecules to form and replicate. In this way, the deep sea may have been both crucible and cradle, shaping the earliest whispers of metabolism. To descend there in imagination is to enter a world without sound, only vibration. The water glows faintly from minerals, sulfuric plumes rise like incense, shrimp cluster around the heat, their shells glinting with iron. Tube worms stand like white candles, feeding on bacteria that convert rock into sustenance. The scene is alien, yet profoundly earthly, a reminder that creation often begins where opposites meet. The ocean remembers those origins still. Trace metals in the water column, essential for plankton growth, are continuously released from vents today, linking the deepest crust to the surface bloom of life. The cycle is unbroken. Elements rise from the seafloor, pass through cells, and return as sediment, ready to begin again. In the rhythm of this exchange, one hears the planet's own respiration, slow, balanced, eternal. The vents breathe out minerals, the ocean breathes them in. Together, they keep the chemistry of life within gentle limits. To think of it is to feel small, but also connected. The iron in our blood, the zinc in our cells, the copper in our nerves, all were once released from volcanic hearts like these. Each heartbeat carries a faint echo of the Earth's molten core, cooled and softened by seawater. Thus, the hypothesis glows even in darkness. The ocean does not simply hold memory, it circulates it, from deep heat to gentle tide. What rises from the black smokers eventually returns as coral, plankton, whale. The deep and the shallow, the hot and the calm, all belong to one continuous breath. So in the quiet between your own breaths, imagine the slow pulse of those unseen volcanoes, the shimmer of minerals rising through night. They are still there, whispering the oldest lullaby of all. That creation never ends. It only changes temperature. By the dawn of the Ordovician period, around 485 million years ago, the ocean had become a painter, and the continents its slow-moving canvas. What had once been a world of scattered volcanic islands was now gathering into broad, shallow seas. Continents drifted like quiet rafts upon the mantle's slow current, carrying life into new latitudes and climates. The world's pulse shifted again. Imagine those seas, warm, clear, and filled with light. Coral ancestors and sponges built reefs that stretched for hundreds of kilometers. Trilobites scuttled across the sandy floor in endless procession. Above them, soft-bodied creatures swam gracefully, early cephalopods with coiled shells, their tentacles trailing behind like ribbons. Plankton flourished, and the water shimmered with suspended life, tiny suns reflecting the new richness of oxygen. The Ordovician Ocean was not deep in most places. Instead, it spread across wide continental shelves, shallow enough for sunlight to reach the bottom. These environments were nurseries of diversity. Every grain of sand was a neighborhood. Every current carried larvae, nutrients, and the echoes of distant storms. The ocean learned the art of distribution, of sending life outward, of spreading memory through motion. Scientists studying the chemical composition of Ordovician limestone find signatures of this thriving equilibrium. Carbon isotopes reveal a stable exchange between atmosphere and sea, suggesting a climate mild and balanced. Yet beneath that calm surface, tectonic plates continued their slow migration. Gondwana, the supercontinent that would one day cradle Africa, South America, and Australia, drifted steadily southward. Its margins sank under the weight of accumulating sediment, drawing the seas inward. In those warm shallows, life continued its quiet revolution. Early fish with jawless mouths began to appear, ancestors of vertebrates. They filtered water through gill slits, tracing the first heartbeat of the creatures who would one day walk the land. Sea lilies anchored themselves to the seafloor, lifting feathery arms into the current. Even algae and microbial films evolved into more complex forms, weaving new fabrics of interaction. And still, the tides moved, pulled by the distant moon, slower now than in the planet's youth. Each cycle of rise and fall left ripples in the sediment, delicate as fingerprints. These patterns hardened into stone, surviving hundreds of millions of years as rhythmic fossils. When geologists find them today, they can read not only the motion of water, but also the length of ancient days, written in the width of each ripple. The Ordovician seas were therefore both theater and clock, recording the choreography of life and the tempo of Earth's rotation. To drift through them would be to float through a symphony tuned to gravity and light. Yet as always, The ocean's serenity held within it the seeds of change. Near the end of the Ordovician, glaciers began to gather at the South Pole. The sea level fell, reefs withered in cooling waters. A quiet crisis unfolded, one of the earliest mass extinctions. Still, even in that loss, the ocean's memory endured. The sediments of vanished reefs became limestone cliffs, and their carbon became the breath of future forests. The drifting continents continued onward, carrying fossils like thoughts pressed into pages. When you walk along an Ordovician outcrop today, perhaps in Wales or Morocco or Ontario, you stand where the sea once hummed. The limestone beneath your feet is a frozen echo of tides that lapped against alien shores. The hypothesis flows through this, gentle and unbroken. Oceans remember not only life, but also its motion. Each collision of continents, each retreating wave, each cooling breeze leaves a trace in chemistry, in rock, in rhythm. The memory does not fade. It only changes form, waiting for minds like ours to listen. If you pause for a moment, you might sense it. The faint vibration underfoot, the ancient hum of continents still moving, the slow sigh of water finding its balance once more. The planet's song continues, deep and low, the same tune that began when the first drop fell from the first storm. Light leaves traces in unexpected places, in the depths of limestone and shale, in the ridges of fossil shells, in the subtle chemistry of ancient minerals. The ocean's radiance is still folded inside. Scientists call these clues paleochemical proxies, the signatures of sunlight, temperature, and atmosphere written into stone. But to think of them another way, they are the ocean's photographs, developed slowly over eons. Each shell that once shimmered in a Cambrian or Ordovician sea held within it a tiny record of the world above. As it grew, it borrowed oxygen and carbon from seawater, atoms whose isotopic ratios depended on the climate, the composition of the air, and even the brightness of the sun. When that creature died and settled into silt, its shell became a capsule, a storage vessel for ancient light. To measure those ratios today is to read the diary of the sea. A heavier isotope of oxygen means cooler water, a lighter one, warmth. Carbon tells of productivity, of plankton blooms and quiet years. Strontium traces the slow weathering of continents. Each layer of rock becomes a verse in an epic poem, describing the planet's pulse in temperature and tide. If you hold a piece of fossil coral under a microscope, you can see fine growth bands, daily, monthly, annual marks, much like tree rings. These lines capture the rhythm of sunlight filtered through water, the heartbeat of the ancient world. Some corals show that there were once more days in a year, 390 or more, when the moon was closer and Earth spun faster. Thus, even the light of day is recorded in calcium and aragonite. The fossil light of the ocean does not simply illuminate the past, it illuminates memory itself. The shells, in their stillness, remind us that perception need not fade when the perceiver is gone. The sea saw, and the sea remembered. During the Silurian and Devonian periods, when reefs expanded across the globe, the chemistry of those shells began to shift again. Higher levels of carbon dioxide made the oceans slightly warmer, slightly more acidic. Corals adapted, changing the structure of their skeletons, altering their internal symbiosis. Through such delicate feedback, the ocean learned to regulate its own brightness, adjusting the thermostat of life by reflecting and absorbing light in measure. Modern oceanographers, tracing these patterns backward, find in them the continuity of radiance. The photons that warmed the first algae are kin to those that sparkle today on wave crests. the light never truly left. It only changed carriers, from sun to shell to sediment. To imagine this is to feel the tenderness of geology. Fossils are not dead things, but letters written in calcium, waiting for us to read them aloud. When a paleontologist splits a rock and reveals the iridescence of an ancient shell, it is as if a beam of stored sunlight escapes into the present. Light that has traveled through the body of the ocean across hundreds of millions of years to reach our eyes. And just as every tide repeats the rhythm of the moon, every glint of light on the water repeats this return. Energy arriving, being held, and released again. The ocean's surface may sparkle for a moment, but that sparkle carries the memory of uncountable dawns. Thus, the hypothesis brightens. The ocean remembers through chemistry and reflection, turning light into lineage. Each shining shell, each polished fossil, each shimmer of salt water carries a little of the same glow. Not metaphor, but matter. If you close your eyes now, you might see it behind your eyelids. The faint pulse of a billion suns diffused through water, softened by depth. The sea, even in darkness, is never without light. It stores it like a heartbeat, waiting for us to notice. By the time the Devonian period unfolded, about 419 million years ago, the Earth had begun to exhale in green. The first true forests rose on land, their roots gripping soil that had never before felt such permanence. And as those roots dug deep, the ocean responded, its chemistry, its breath, its very balance shifting to meet this new companion world above. Rivers, for the first time, carried rich sediment into the sea. Minerals, organic matter, dissolved nutrients. The water grew murkier near the shores, but richer in sustenance. Plants drew carbon dioxide from the air, cooling the planet and sending excess oxygen cascading into the oceans. Every leaf that trembled in sunlight altered the rhythm of the tides, for the sea and the sky were learning to breathe together. The Devonian transformation is sometimes called the Age of Fishes, but it was also an age of synthesis. Reef systems flourished again after Ordovician extinctions, building structures rivaling modern coral expanses. Among them swam armored placoderms, fish sheathed in bone like living sculptures, and early sharks, sleek and electric with motion. Jawless ancestors gave way to agile predators, the ocean testing new designs of motion and sense. Below them, plants and algae colonized shallows, forming underwater meadows. Trilobites persisted, though their dominance was waning. Ammonites, with spiral shells, began their graceful reign. Every current, every layer of light, carried the mingled breath of ocean and forest. The biosphere had become one system, joined by wind, water, and carbon. Geochemists find in Devonian rocks a subtle signal of this new harmony, an oxygen spike recorded in iron oxides and sulfates. The ocean's deep zones, once starved of air, began to awaken. But balance is delicate. In certain basins, nutrient-rich runoff caused blooms of plankton that consumed oxygen as they decayed. Temporary anoxic events spread through low-lying seas, reminders that abundance carries its own fragility. Still, even in those darkened depths, life persisted. Some fish developed the ability to gulp air, rising periodically to the surface. Others strengthened their fins, feeling for purchase along the muddy banks. In these hesitant gestures, the memory of water prepared itself for land. Evolution, as always, was both continuity and rehearsal. If you could stand on one of those early shores, you would see a world half underwater, half dreaming. Trees with trunks like spirals reached upward, Dragonflies the size of sparrows skimmed the air. The horizon shimmered with mist where rivers met the sea. Every breath of wind carried spores, salt, and the faint scent of growth. And beneath that shimmering surface, reefs stretched outward like living continents. Their builders, corals, stromatoporoids, and algae, layered calcium carbonate into grand terraces. Fish sheltered in their crevices. Currents flowed through like blood. When these reefs finally perished, buried under sediment, they became vast reserves of limestone, future mountains waiting quietly beneath our feet. The ocean's memory deepened in this era, not only in chemistry, but in connection. It began to reflect the land's changes instantly, as if sharing a nervous system. When forests expanded, carbon levels shifted. When rivers swelled, salinity changed. The planet was becoming self-aware through feedback loops, a slow intelligence expressed in balance. And so, the hypothesis breathes through this age. The ocean remembers not as an observer, but as a participant. Every leaf that fell into a stream carried a message to the sea. Every wave that returned to the sky brought news of the deep. In that exchange, life found rhythm, not in isolation, but in dialogue. Now, when we watch rivers turn golden at sunset or smell rain carried from distant coasts, we are feeling that same communion. The ancient conversation continues, gentle as tide against root. The forests exhale, the oceans inhale, and the planet dreams between them. The Devonian seas shimmered with light and danger, yet even their predators moved with the unhurried rhythm of deep time. By now, evolution had perfected jaws, fins, and eyes, the tools of pursuit. But the chase itself was still a kind of dance, patient and circular. In the stillness between waves, hunter and prey both seemed to follow the same ancient choreography. Among the first true predators were the placoderms, armored fish heavy with bone and grace. Their skulls were plated like mosaics, each ridge and hinge a testament to the precision of natural design. Dunkleosteus, the largest of them, could reach lengths of 6 meters. Its jaws snapped shut with the force of a crocodile, yet its movements through the water were slow, deliberate, almost ceremonial. It hunted not in frenzy, but in rhythm. In those same seas glided the cephalopods, the early kin of modern squid and octopus. Many bore coiled shells, perfect logarithmic spirals balancing buoyancy and symmetry. Their tentacles, armed with primitive suckers, reached into the currents for drifting prey. Their eyes, large and complex, mirrored the starlight filtering from above. These creatures embodied the ocean's reflective intelligence, flexible, curious, and endlessly adaptive. The balance between predator and prey became the ocean's newest experiment in memory. Each adaptation written into muscle or shell was a response to something remembered, a near miss, a successful strike, a rhythm of pursuit and escape. Over generations, these experiences accumulated, sculpting forms that could anticipate the flow of water before it moved. In the shadow of coral reefs, smaller fish hid in schools, their silver bodies flickering in synchronization. This collective motion, the shimmer of many acting as one, confused the eyes of their hunters. It was a strategy born from unity, from remembering together. The ocean, as always, learned through collaboration as much as competition. To drift among these creatures in imagination is to enter a ballet of fluid motion. Light refracts through the water, outlining placoderms like living statues, their armor glinting gold in the green gloom. Cephalopods hover nearby, pulsing gently, their color-changing skins rippling through patterns of camouflage and communication. A sudden twist, a flash, and the water returns to stillness, as if nothing had ever happened. Even predation, at this scale, was part of the ocean's serenity. The cycle of life and death flowed as seamlessly as tide. Energy transferred without cruelty, only continuity. Each movement dissolved into the next. Each end became sustenance for another beginning. Fossil evidence tells us that eyes in this period reached new sophistication. The evolution of crystalline lenses and retinae capable of detecting subtle light gradients allowed creatures to sense motion at incredible distances. Some scientists call this the visual revolution. With vision came awareness, a new way for the ocean to perceive itself. For the first time, light had not only a surface to reflect from, but a gaze to meet it. The predators of the Devonian were, in a way, the ocean's first conscious mirrors. Their hunts were acts of perception, moments when the sea recognized its own vitality and motion. Every leap, every spiral, every narrowing pupil was part of that recognition. And through all this, the moon still pulled the tides, steady as a metronome. Night descended. Bioluminescent plankton drifted through the dark, glowing faintly as if marking the paths of unseen swimmers. The ancient hunters glided silently through this field of stars, their shadows passing across constellations of light. The hypothesis deepens in this luminous quiet. The ocean remembers not only the calm, but the chase, not as violence, but as continuity. The energy that drives a predator to move is the same that stirs plankton to drift, the same that turns molecules to life. The difference is only scale, only tempo. Now, in our own stillness, we echo that same rhythm. The pulse that beats in our wrists once belonged to fish who hunted beneath a young sky. The curiosity in our eyes was first tested in cephalopods who gazed through green water, wondering what moved beyond. All of it, motion, hunger, perception, is memory, passing forward like light through a lens. And the sea, ever patient, carries the reflection onward. Every long rhythm carries its silences. After the Devonian symphony of light and motion came the first great pauses in life's song. The deep time crises, moments when the ocean exhaled and much of what lived upon it faded away. These were not sudden cataclysms, but slow unravelings woven through chemistry, temperature, and chance. Near the end of the Devonian, around 375 million years ago, reefs began to wither. Forests on land, once the planet's new lungs, had drawn down so much carbon dioxide that global temperatures dipped. Weathering of freshly exposed soils sent nutrients rushing into rivers, feeding plankton blooms. When those blooms died, they consumed oxygen, leaving the shallows breathless. Whole stretches of sea turned dark and still, a mirror too calm for movement. This late Devonian extinction did not strike all at once. It came in waves, like a tide that retreats, returns, and retreats again. Each pulse erased a little more. Coral systems collapsed. Armored fish vanished. Trilobite families dwindled. Yet in the sediments left behind, we find the record of recovery already beginning. Life's persistence is written in overlapping layers: loss and renewal, silence and return. Geologists can see these intervals as thin black bands in limestone, rich in organic carbon, poor in oxygen. They are planetary pauses, imprints of absence. But absence, too, is memory. The ocean remembers what it once held by the shapes left behind, by the chemistry of what remains. To imagine this time is to picture a world of soft twilight. The surface may still have sparkled, but below, the water was sluggish and shadowed. Few creatures stirred. In that hush, evolution reconsidered itself. Some survivors retreated to deeper, cooler refuges. Others adapted, learning to breathe in new ways or to live where oxygen was scarce. Even extinction has creativity folded within it, the ocean's way of editing its story. And slowly, recovery followed. New corals, new fish, new plankton species rose from the depths. The ecosystems that emerged were different, but no less intricate. What had been lost became the foundation for something subtler, as if the sea had paused, turned a page, and begun a quieter chapter. Scientists studying modern oceans sometimes look to these ancient crises for perspective. They remind us that the planet's memory is vast, its capacity for renewal profound but not infinite. When oxygen levels falter today, when reefs bleach and currents slow, the ocean is not simply suffering, it is remembering. It has been here before, and it knows both loss and return. In that light, the hypothesis takes on its most compassionate tone. The sea's resilience is its memory. Each extinction has taught it a new way to sustain life, each recovery a new rhythm of balance. The ocean endures by evolving, by holding within its depths both what has vanished and what is yet to come. If you listen closely, in the hush between waves, in the low hum beneath a storm, you can almost hear it. A sigh older than continents, an acceptance beyond grief. The sea does not mourn as we do. It folds even tragedy into continuity. On some future shore, long after us, new beings may find our traces in the same way we find trilobites, faint imprints in layered stone. And the ocean, patient as ever, will carry those too, adding them to its collection of memories. For in deep time, nothing is truly lost. Energy changes form, silence becomes possibility. The sea holds it all, the blooming, the breaking, the return. And through that cycle, the planet keeps its pulse, steady and slow, as if whispering, remember, and begin again. After the long quiet of the Devonian losses, the ocean began once more to rebuild itself. By the Permian period, some 300 million years ago, the Earth had gathered its wandering continents into one great landmass, Pangaea, and the seas between its arms shimmered with renewal. Life had learned from its earlier silences. The reefs returned, but they were different now. Tighter knit, stronger, more intricate in their partnerships. Microbes led the way. Cyanobacteria, ancient survivors from the planet's earliest light, spread again across shallow waters, weaving thin mats of life across new coastlines. On these living carpets, sponges anchored themselves, corals found foothold. Together, they formed vast carbonate structures, reefs so extensive they stretched hundreds of kilometers along tropical shelves. Geologists call them Capitan reefs, and their fossils line cliffs in what is now Texas and the Ural Mountains. Within those walls, the sea rehearsed its resilience. Each layer was a story. Microbial film, coral skeleton, sponge lattice, sediment dust, all stacked in patient alternation. The reefs grew upward like time itself, recording seasons of growth and quiet in repeating bands. Viewed in cross-section, they resembled tree rings of the sea, each marking a year of light, temperature, and tide. The chemistry of these reefs reveals oceans in balance. Carbonate minerals, calcite and aragonite, formed easily in the warm, clear water. Oxygen levels were high. Currents flowed gently between the continents. Fish and mollusks thrived in the shadowed crevices. Crinoids lifted their arms toward the filtered sunlight. It was a moment of equilibrium, a breath between upheavals. But beneath the calm, the planet was stirring again. Volcanic rifts in what is now Siberia began to exhale enormous plumes of carbon dioxide and methane. Slowly, the air thickened. Temperatures rose. The ocean, that old keeper of balance, tried to absorb the excess, but memory has limits. Too much carbon dissolved into seawater, altering its chemistry, making it harder for shells and corals to form. The Permian reefs faltered. Then came the breaking point. The Great Dying, around 252 million years ago, the largest extinction in Earth's history. More than 90% of marine species disappeared. The seas became acidic, warm, anoxic. For millions of years, the ocean's surface shimmered with microbial films, purple and green mats fed by sulfur, echoing the colors of Earth's youth. And yet, life did not end. Beneath the surface scum, deep in cooler trenches, microbial colonies persisted. They recycled nutrients, detoxified the water, and waited. These unseen chemists, the smallest of all, kept the spark alive. The planet's memory condensed once more into its simplest form, molecule by molecule, reaction by reaction. From that simplicity, renewal again emerged. When conditions stabilized, new coral lineages evolved, sturdier, more adaptable. Mollusks diversified, plankton returned to the sunlit layers. Within 10 million years, the ocean's color shifted back from murky violet to blue. The Great Permian Silence gave way to the first whispers of the Mesozoic seas. This pattern, collapse, pause, rebirth, is the rhythm that underlies all of oceanic history. Each reef that rises carries within it the minerals and lessons of the last. The sea builds with memory, not from scratch. Its architecture is recursive. Every extinction becomes the scaffolding for what follows. Modern scientists trace this lineage through the geologic record, finding microbial fingerprints at every recovery horizon. Wherever life falters, microbes return first, exhaling oxygen, stabilizing chemistry, preparing the stage. They are the ocean's archivists, copying the code of resilience across epochs. So when we look today at coral reefs glowing under sunlight, we are seeing the latest chapter in an unbroken manuscript. The same collaboration of stone and softness that once graced the Permian shelves. And though those ancient reefs lie silent now, their calcium stories continue to shape modern tides. The hypothesis rests gently here. Memory, in its truest form, is persistence through transformation. The ocean never forgets, because its smallest voices never stop working. Close your eyes and imagine one of those ancient reefs, alive again beneath warm, shallow light. Every pore breathing, every layer alive. The sound you might hear, if sound could travel through time, would not be a roar, but a whisper. The hush of microbes rebuilding the world. When the ocean finally recovered from the Great Dying, it opened its eyes to a new world. It was the Mesozoic, the age of reptiles, and above the sea, the continents were stirring like giants waking from long sleep. Between their edges lay shallow lagoons and inland seas, warm as breath and green with plankton bloom. It was in these tranquil basins that the ocean began another chapter of memory, one of buoyancy, grace, and drift. The new reefs, born from survivors of the Permian Silence, spread again across tropical shelves. Corals of modern design built colonies with complex polyps and symbiotic algae, perfecting the balance of sunlight and stone. In their shadows, ammonites spiraled upward in iridescent shells, while delicate crustaceans brushed the sediment below. The sea had found color again. Above these gardens glided the great marine reptiles, ichthyosaurs shaped like dolphins, plesiosaurs with long necks that curved like ribbons through the light. Though they ruled the water as dinosaurs ruled the land, their motion was astonishingly quiet. Fossil trackways show no signs of struggle or chaos, only fluid arcs, gentle turns. The choreography of creatures perfectly attuned to the buoyancy that held them. They inhaled, dove, and rose again, tracing slow spirals through the layered water. Some gave birth to live young in mid-ocean, never needing land. Their skeletons, preserved in limestone beds, reveal embryos curled like commas, the punctuation of an ancient sentence still being written. Drifting around them were the new masters of the microscopic world, plankton, whose shells of calcium and silica settled endlessly through the water, creating a snowfall of memory. Over millions of years, those shells would pile into chalk beds hundreds of meters thick, bright white deposits that now gleam in cliffs from England to Egypt. The famous white cliffs of Dover are, in essence, condensed sunlight, the remains of plankton who turned light into mineral, then fell gently into rest. In the stillness of a Mesozoic lagoon, one might have seen both scales and stars. Bioluminescent plankton flickered at the surface, glowing blue beneath the night sky. Each wave rolled light over light, starlight above, microbial light below, and for a moment, the boundary between sea and sky blurred. The ocean was remembering the same luminosity it had first held in its primordial depths. Scientists studying the microfossils of this era, coccolithophores, foraminifera, radiolarians, can read global climate in their patterns. The thickness of their shells tells of carbon balance, the species distribution of ocean currents. Even the tilt of Earth's axis and the timing of monsoon cycles are archived in these tiny bodies. The ocean's smallest creatures became its most precise historians, and though the Mesozoic seas hosted giants, their true architects were invisible. The plankton regulated carbon dioxide, cooled the air, and fed the deep through their steady rain of shells. Every great predator, every coral, every ripple of oxygen owed its existence to that delicate drift. The rhythm of life in these lagoons was not violent, but layered. Fish glided between corals, ammonites rose and fell with the tide. Algae carpeted stones in soft greens, while sea lilies unfurled their arms like underwater ferns. If one could float there, time would seem suspended. The water warm, the air fragrant with salt and bloom, the horizon always shifting between blue and gold. The hypothesis continues. The ocean remembers through repetition, not permanence. The same calm lagoons that once nurtured microbial mats now hosted reptilian grace. The same plankton that cooled the Devonian seas built chalk from Mesozoic sunlight. Each era borrowed the same materials and rewrote them in new grammar. And so, memory thickened, not as nostalgia, but as continuity. The sea, in its unhurried cycles, carried every detail forward. The gentle glow of plankton, the slow flight of ichthyosaurs, the dust of calcium falling like snow, all became part of its ongoing dream. If you close your eyes now, you might picture that lagoon at dusk, a still mirror reflecting a lavender sky, broken only by the ripple of a passing fin. Beneath it, a billion drifting shells settle softly towards sleep. The ocean, at peace once more, hums with quiet endurance and the memory of warmth. By the close of the Mesozoic, the world had begun to take a shape we would recognize. The single supercontinent of Pangaea cracked apart, its fragments gliding slowly across the mantle like ice flows on a deep current. Between them, new basins opened, the ancestors of today's Atlantic and Indian Oceans. The sea was, once again, in motion, redrawing its own map. Where there had once been shallow lagoons and inland seas, there now formed great pathways of salt water. The newborn Atlantic spread from a narrow rift to a widening gulf, bordered by volcanic ridges that breathed out heat and minerals. On its floor, basalt cooled into symmetrical bands, the stripes of seafloor spreading, silent proof of the Earth's restless heart. Scientists reading those magnetic lines can track the planet's pulse as it expanded, each band marking a reversal of polarity, a cosmic rhythm of north and south. The ocean, even as it grew, carried the memory of magnetism within its stones, the unseen compass guiding all movement. The Cretaceous period, the last act of the Mesozoic, was a time of warmth and fullness. Global sea levels rose, continents flooded. Shallow epicontinental seas stretched across North America and Eurasia, connecting ecosystems in gentle gradients. The waters teemed with life. Ammonites and belemnites coiled upward. Fish darted through coral palaces, and new species of plankton filled the skies of water with white rain. Even as dinosaurs thundered across the land, the true transformation was happening beneath the waves. Tiny calcareous organisms, foraminifera, coccolithophores, algae, were recording every breath of the atmosphere in their shells. Layer by layer, they built archives of temperature and chemistry that scientists still decipher today. Each shell was a data point, each sediment a memory cell. The ocean had become the planet's most faithful historian. As the continents drifted apart, ocean currents began to stabilize. Water could now circle the globe without interruption, distributing heat and nutrients more evenly. The first outlines of the modern thermohaline circulation, the global conveyor belt, emerged. This was the ocean's new heartbeat, slow and steady, connecting polar cold to equatorial warmth in one continuous loop. In this stability, marine life diversified further. Corals refined their architectures, bony fish mastered efficiency, marine reptiles gave way to new lineages of sharks and turtles. Each lineage carried echoes of its ancestors, each adaptation an annotation in the long book of survival. The sea did not discard its memories. It folded them into new forms. Near the end of this age, change returned, as it always does. A meteorite's impact, massive and incandescent, drew the curtain on the Mesozoic drama. Dust veiled the sun. Temperatures fell. 3/4 of marine species vanished. Yet once the skies cleared, the ocean resumed its patient rebuilding. Within a few million years, reefs flourished again, and small mammals began to explore the shoreline. The Cenozoic oceans, the ones we know, rose from that silence. Their chemistry, salinity, and circulation became the stable background of modern life. Continental drift continued to shape coastlines. India moved north to meet Asia, birthing the Himalayas. Antarctica settled at the pole, growing its first ice cap. Each collision and separation altered the ocean's breath, sending new currents through its vast lungs. To stand on a beach today is to look upon the result of that long choreography. Every horizon line, every curl of wave, carries the imprint of 200 million years of motion. Even the sand beneath our feet, grains of quartz and shell, is a mixed inheritance, ground from the bones of reefs, mountains, and plankton alike. The hypothesis flows easily here. The modern ocean is not new at all, but the sum of its past selves. Every rearranged current still hums with the memory of ancient tides. The continents may wander, but water remembers its pathways. So when you listen to the hush of surf against stone, you are hearing more than weather and wind. You are hearing the long conversation of plates and depths, of continents finding balance. the ocean continues to write itself in waves, each one a syllable of an ongoing sentence that began when Earth was young. And though the names of seas have changed, Tethys to Atlantic, Panthalassa to Pacific, their essence has not. They are one body, one memory, flowing through time with the calm persistence of breath. The story of the sea's renewal after the great extinctions is often told through coral and current, but the true authors of its calm were smaller than dust. They were the diatoms and foraminifera, single-celled artisans who wrote history in glass and chalk. Every molecule they touched became a verse in the ocean's unfolding poem. Diatoms, born in the Cretaceous twilight, are creatures of light. They weave shells of silica, opaline glass, with patterns so precise they rival architecture. Under magnification, each frustule gleams with symmetry, lattices of circles, ovals, and spirals delicate as snowflakes. Floating in the sunlit layers, they turn photons into sugar, drawing carbon from water, releasing oxygen in quiet abundance. Every breath we take still carries their signature. Foraminifera, their chalk-bodied counterparts, live within tiny carbonate chambers. As they grow, they build new rooms, spirals of memory expanding outward. When they die, their shells drift downward, a soft rain of calcite that carpets the seafloor in white sediment. Over millions of years, these fallen bodies compress into limestone, chalk, and marl, entire mountain ranges born from microscopic endurance. Scientists study these remains with reverence. In their chemistry, they find records of temperature, salinity, and current flow reaching back tens of millions of years. A change in the ratio of oxygen isotopes, a shift in trace elements. Each is a word in the ocean's long diary. The smallest fossils reveal the largest truths. If coral reefs are the ocean's cities, then diatoms and forams are its poets, describing every change in mood and tone. They are the memory cells of the planet's body, living, dying, and sinking in endless rhythm, composing the ocean's self-portrait grain by grain. Imagine drifting among them, suspended in the photic zone. Sunlight filters through layers of plankton like light through stained glass. The water glows with soft greens and golds, every drop teeming with geometry. Each diatom turns and tumbles gently, its glass shell catching and scattering color. Beneath you, the invisible snow of calcium descends, slow as thought, building a future seabed. Even in their stillness, these creatures are dynamic. A single teaspoon of seawater can hold thousands of diatoms, each capturing the day's light and converting it into memory. When they bloom in unison, they tint whole regions of ocean turquoise or jade, ephemeral paintings on the world's largest canvas. The foraminifera, meanwhile, drift lower, their shells thickening as they age. Some carry symbiotic algae within their chambers, harvesting sunlight like miniature gardens. When they settle at last upon the bottom, they form new layers of time, soft and white as sleep. Every handful of chalk, every limestone cliff, every page of a geologic map is their handwriting. This too is part of the ocean's gentle persistence, the transformation of fragility into endurance. What begins as a whisper of light inside a glass cell ends as the substance of mountains. The world's cliffs and cathedrals owe their stone to creatures too small to see. The hypothesis glimmers here. The ocean remembers most faithfully through its smallest voices. Its archives are not grand monuments, but layers of powder, quiet accumulations that outlast empires. Each diatom shell is both a gravestone and a stanza, a tiny perfection dedicated to continuity. To hold a piece of chalk between your fingers is to touch an ancient bloom. To walk along a limestone shore is to tread on the compressed breath of sunlight itself. The sea's poets lie beneath our feet, their verses carried by waves, their story still being written in every current that passes. So tonight, when you look at a glass of water catching light, imagine it magnified into the world of diatoms. Each spark a syllable, each shimmer a memory. The ocean is never silent. It simply speaks in scales too small for our eyes. Beneath the luminous skin of the surface, far below the reach of sunlight and color, the ocean keeps its most patient rhythm. It moves not in waves or storms, but in slow, planet-spanning breaths, a circulation of salt, temperature, and memory. Scientists call it the thermohaline circulation, the global conveyor of heat and minerals, but to the Earth, it is simply breathing. This current begins at the poles, where cold air thickens the surface water until it sinks, carrying oxygen and trace elements into the depths. From there, the water drifts along the ocean floor for centuries, touching continents in silence, gathering stories in chemistry. When it rises again, thousands of miles away, it brings with it nutrients from the dark, a quiet generosity that feeds plankton, coral, and fish alike. The timescale of this motion is vast. A single molecule of water may take 1,000 years to complete the circuit, from pole to equator and back. The ocean, then, remembers centuries in every breath. It is the slowest pulse of the living planet, a heartbeat measured not in seconds, but in ages. The modern world knows this rhythm as the global ocean conveyor belt. It unites the Atlantic, Pacific, Indian, and Southern Oceans into one continuous loop. Temperature, thermo, and salinity, haline, act as its twin guides. Cold and salt make water heavy, warmth and rain make it rise. Each imbalance sets the next movement in motion, like an inhale answering an exhale. Even the tiniest changes in this cycle alter the planet's climate. During the ice ages, meltwater freshened the seas, slowing the current. Temperatures fell. When salinity returned, the current strengthened, and warmth returned to the poles. The ocean has moderated Earth's fever and calm for millions of years, a physician of equilibrium, remembering how to heal itself. To imagine this hidden river is to picture a vast, unbroken loop of motion, silent as sleep. In the abyssal plains, the water moves like shadow over the seafloor, stirring sediments that have not seen light since the Devonian. Each grain it touches becomes a record, a memory dusted and rewritten. Above, in the midwater twilight, marine snow drifts downward, adding fresh stories from the surface. Fragments of plankton, flakes of calcium, threads of protein. Together, they make the sea's slow snowfall, the material of continuity. The thermohaline current binds every living thing. The warmth that reaches a coral reef in the Pacific may begin as cold brine in the North Atlantic. The iron-feeding plankton blooms off Antarctica once rose from volcanic vents beneath Iceland. Through this flow, the planet speaks to itself, ocean to ocean, century to century. Modern oceanographers track the current with floats and satellites, measuring the slow turn of the planet's aqueous lungs. What they find is not chaos, but pattern. Oscillations that stretch across decades, centuries, and beyond. Some compare these cycles to the slow breathing of sleep, an inhale of cold water sinking, an exhale of warmth returning to the surface. Even human rhythms echo this deep pulse. Our lungs follow similar patterns of density and exchange. Oxygen drawn in, carbon released. The same physics, the same elegance of balance. We, too, are thermohaline beings, made of salt water that remembers the tide. If you listen in imagination, you might hear that ancient circulation beneath the noise of waves, a low, continuous hum, the sound of the planet thinking. It carries no urgency, no hurry, only persistence. Every current, every eddy, every returning flow says the same thing. I have been here before. And perhaps that is why the ocean feels so calming to us. Its rhythm aligns with something inside, the deep inheritance of balance, the reminder that movement and stillness are one. When you breathe slowly beside the sea, your pulse syncs with the turning of the thermohaline tide, and for a moment, you and the planet share a single breath. Before there was song, there was vibration. In the hush of the deep, where light cannot reach, the ocean learned to communicate through motion. Tiny oscillations carried by water's dense embrace. Every drop of the sea is a medium of resonance, each molecule a messenger of tone. Long before creatures spoke or sang, the birth of sound had already begun. Water carries sound almost 5 times faster than air. A single click, pulse, or sigh can travel across hundreds of kilometers if the layers of temperature and pressure are right. Scientists call this the SOFAR channel, the deep acoustic pathway where sound bends and lingers, trapped between warm surface and cold abyss. It is the ocean's ear and memory combined. The first voices were not voices at all. They were the soft drumming of volcanic vents, the rumble of shifting plates, the rhythmic heartbeat of waves against basalt. These vibrations filled the ocean's body like a language without words. Later, as life expanded, evolution learned to listen. Early fish sensed these tremors through lateral lines, delicate organs that felt pressure changes in the water. It was not hearing yet, but awareness, a way to know the presence of others in the dark. From this perception grew connection. Shoals moved as one, predators hunted unseen, and the sea became alive with silent conversation. When mammals returned to the water millions of years later, they inherited that old capacity and magnified it. Whales, dolphins, and seals transformed pressure into music. The cetaceans, in particular, turned the ocean into an instrument. Their low-frequency songs can circle the globe, weaving through the SOFAR channel like threads of memory. Imagine a blue whale's call, a note deeper than human hearing, yet powerful enough to travel from one ocean basin to another. Within it lies not just communication, but continuity. Each generation repeating, reshaping, and passing on the patterns of its ancestors. Modern researchers have found that these songs change slowly over time, evolving like dialects, like living history sung through salt water. Even smaller beings joined this acoustic tapestry. Shrimp clicked, fish drummed, coral reefs hummed with the collective buzz of countless mouths and fins. At night, biologists lowering hydrophones into tropical lagoons hear what they call reef chorus, a steady, rhythmic hum, the sound of life itself. The sea is never truly silent. Its stillness is a kind of music too low for the untrained ear. Some sounds arise from motion alone. Icebergs calving at the poles release bell-like chimes. Sand shifting along the seabed rasps like breath. Rain on the surface becomes applause. Each of these tones carries memory, a record of interaction between water, temperature, and time. The ocean also keeps echoes. Low-frequency sounds can reverberate for hours, even days, tracing unseen corridors through the deep. In this way, the ocean holds its own auditory past, a resonance that outlasts the moment of creation. For marine life, sound became both compass and comfort. Whales navigate by it, recognizing coastlines through their echoes. Dolphins identify one another with signature whistles. Some fish use drumming calls to mark territory or reunion. In the dark, sound replaced sight, and community replaced solitude. The hypothesis hums softly here. The ocean remembers not only through chemistry and light, but through resonance. Every wave, every heartbeat, every call becomes part of an unbroken continuum of vibration. The sea is a great resonant archive, where energy becomes information and then fades, leaving only harmony behind. When we stand by the shore and hear the low thunder of waves, we are hearing more than weather. We are hearing the oldest form of memory still in motion. Pressure turned to music, movement turned to meaning. So breathe for a moment and let that sound settle inside you. It is the same vibration that once guided trilobites, that still carries a whale's song beneath the ice, that moves now through your chest as the steady rhythm of your own pulse. The ocean, through sound, reminds all living things of their shared vibration, the slow, eternal hum of being. Every breath of wind that brushes the sea leaves a trace. Every rainfall, every drift of dust from a distant continent, every volcanic sigh settles into water and is remembered. The ocean is the planet's slow archive, recording in ions what the sky forgets in clouds. Its memory is not written in ink or image, but in ratios, the quiet arithmetic of isotopes. Scientists reading this chemical script speak of D18O and D13C, of trace metals and rare gases, clues locked in shells and sediments. These values tell of warmth and ice, of drought and flood, of circulation and stillness. The sea keeps all of it, arranging molecules as though filing away thoughts for future retrieval. A shell that once floated on the surface 1,000,000 years ago may contain more than calcium. Within it lie the fingerprints of ancient rain, the taste of prehistoric air. When geochemists dissolve that shell and measure its isotopes, they resurrect climates long vanished, oceans too warm or too cold, monsoons that came and went like slow heartbeats. In this way, the water remembers for the planet, and rock becomes the sea's diary. Even the deep holds records in its darkness. Layers of sediment, chalk, clay, silt, stack like pages, each a faint residue of weather, life, and decay. Cores drawn from the abyss reveal stories that stretch beyond human imagination. The waxing and waning of ice ages, the rise of reefs, the fall of species, all preserved in whispers of chemistry. These are isotopic whispers, the ocean's secret language of balance. Oxygen isotopes mark the dance between evaporation and ice. Carbon reveals how much of the sun's energy life managed to capture. Strontium, barium, neodymium, each element hums a subtle tune about rivers and mountains, about continents worn down grain by grain. Through such signals, scientists have traced the ocean's role as both witness and participant. When carbon dioxide rises, the sea absorbs it. When it falls, the sea releases it. The result is a breathing pattern measured across millennia, a planetary respiration visible in isotope graphs that undulate like slow waves. But beyond data and graphs lies a quieter truth. The ocean's slow memory is also emotional in its way. It holds sorrow in acidification, joy in clarity, fatigue in stagnation. It reacts always with patience. When human industry adds carbon to the air, the ocean takes most of it, softening the impact, though at a cost to its own coral and shell. This too is remembrance, the willingness to bear the weight of history. In every droplet, the past remains suspended. Hydrogen atoms in the sea today have cycled through countless incarnations. vapor, ice, blood, rain. The same molecule that cooled a dinosaur's skin might now drift past your fingertips at the beach. Water, in its persistence, is memory reincarnate. This chemical continuity binds all time together. The rain that fell on the Ediacaran fronds, the tide that rocked Cambrian reefs, the monsoon that fed Devonian forests, all still circulate, rewritten but unforgotten. The sea is the bloodstream of the earth, carrying not only salts and nutrients, but recollections of everything that has ever touched it. To think of this is to realize that the ocean's calm is not emptiness, but comprehension. Its stillness is dense with experience, its transparency a kind of wisdom. In every layer, the record remains, invisible to the eye, but audible to the instruments that listen, and perceptible to the mind that slows enough to feel it. The hypothesis now hums at full depth. The ocean's true intelligence lies in retention. What for us passes into memory fades. For the sea, it only transforms. Nothing is lost, only dissolved, diffused, rearranged. So if you stand by the water and let the wind touch your face, know that the air brushing your skin carries the same isotopes once released by an Ordovician tide. You are inhaling history. You are part of the sea's equation, an entry in its infinite ledger. And when you exhale, the ocean listens. A gentle acknowledgement, a ripple in its long remembrance. After billions of years in which the ocean shaped life from silence, one small branch of that life learned to name its maker. Humanity, children of salt water and sunlight, returned to the sea not as instinct, but as remembrance. Our blood still carries its chemistry, our cells its salinity. Every heartbeat is an echo of tide. When we gaze upon the horizon, something ancient in us recognizes home. At first, our return was hesitant. We followed rivers downstream, built rafts from hollowed wood, and drifted along coasts. The earliest sailors carried fire, grain, and stories, but they also carried awe. They saw in the ocean both danger and divinity, a mirror too vast to conquer, too patient to forget. Ancient mariners in Egypt, Polynesia, and Greece each found ways to navigate by the stars, yet all relied, knowingly or not, on the moon's rhythm, that same lunar pull that once guided microbial mats and coral tides. As we explored, we began to map not only distance but depth. With ropes, lead weights, and later sonar, we traced the contours of unseen valleys and mountains, the world beneath the world. We discovered that the seafloor was not featureless, but alive with motion. Spreading ridges, trenches, volcanoes, the mid-ocean scars of Earth's breathing. Every measurement confirmed the same truth. The ocean is dynamic, ancient, and intimately aware of change. By the 20th century, our return deepened. Machines descended where lungs could not. Submarines, bathyscaphs, and remotely operated vehicles slipped into darkness, carrying lamps that pierced the black like wandering stars. In 1960, humans first reached the bottom of the Mariana Trench. They found not emptiness, but life. Translucent creatures, glowing with internal light, drifting like thoughts at the edge of dreams. That descent was more than exploration. It was reunion. We had gone back to the womb of the planet, to the pressure and quiet that once nurtured all beginnings. And in that stillness, we rediscovered humility. For even with our machines, we had touched only a fraction of what exists. Less than 10% of the ocean floor mapped in detail. Less than 1% directly visited. The rest remains patient, unseen, unhurried. Yet we have also marked the sea with our memory in ways less gentle. Plastic and carbon now mingle with its currents. Microfibers drift among plankton. The warmth of our engines seeps into its depths. The ocean bears these traces without accusation. It absorbs, dilutes, and remembers. In doing so, it becomes both witness and healer, balancing our noise with its silence. Still, when we pause and listen, awe returns. Divers describe the feeling of being suspended in time, heartbeats slowing until they match the rhythm of distant whale song. Astronauts looking back at Earth call it the blue planet, because from space, all that truly gleams is ocean. Water defines our home more than land ever could. In recent decades, scientists have begun studying not only the ocean's data, but its calm. They measure how proximity to waves lowers blood pressure, steadies breath, and eases thought. The brain's rhythm syncs with the slow cycle of surf, proof that the ocean's pulse and ours were never separate. When we stand at the edge of water, we remember a kind of equilibrium older than words. Perhaps that is why we build rituals around return, pilgrimages to shorelines, songs that imitate the sea's lull, stories of origin and rebirth. The ocean calls not for conquest, but for reflection. It reminds us that knowledge and stillness are one, and so the hypothesis nears its resolution. Humanity's fascination with the ocean is not curiosity alone, but memory. We are the sea recalling itself through human thought, rediscovering in wonder what water has always known, that continuity is peace. As the tide withdraws and the stars return, imagine the planet breathing around you. The ocean lies quiet but alive, recording each sigh, each shimmer, each word. And somewhere, far below, light still drifts through the dark, carrying our reflection home. At last, the story circles back to stillness. The ocean rests beneath moonlight, its surface quiet but aware. Every current, every echo, every breath of wind across it is memory made visible, a living mirror in which the planet sees itself. All the forces that shaped it, heat, ice, light, chemistry, time, are still present in each drop. Nothing has truly left. The molecules that once touched the first volcanic stones, that carried oxygen through Ediacaran bodies, that cooled the scales of ancient fish, drift now in the same tides that brush our shores. The ocean's consciousness is continuity itself. To stand beside it is to feel perspective loosen. Human time, brief, urgent, bright, dissolves into geologic calm. Waves approach and retreat in a rhythm older than breathing, smoothing thought until only presence remains. It is here, in this quiet, that the ocean becomes both mind and mirror. Mind, because it remembers without effort. Mirror, because it reflects without judgment. For billions of years, the sea has practiced patience. It has seen continents wander, species rise and vanish, climates swing from frost to flame. Through all of it, its pulse remained. It did not resist change. It absorbed it, folded it inward, turned it into story. That is its secret: transformation without loss. When we listen closely, we realize the ocean and the mind are not separate things. Both are vast interiors where memories settle, diffuse, and reshape. Both hold sorrow and renewal in equal measure. Both move between depth and surface, silence and song. And both, when still, reflect light perfectly. Imagine now the last drift of this long journey. The stars shimmer above the water. The tides slow into evening. The waves no longer sound like motion, but like breathing. Somewhere deep below, plankton glow in steady pulses, faint as thought. The world's first light meets its last reflection, and between them is peace. The ocean does not end. It only continues beyond our sensing. Its memory carries forward, unbroken, into every cloud, every river, every living pulse. It remembers us already, folded gently into its equations of carbon and salt, its endless sleep and waking. So let the night draw closed like a tide returning home. Let the air cool, the body soften, the mind settle into the same quiet balance that keeps the seas in place. The ocean has told its story, of birth and bloom, of rhythm and return. Its voice fades now to a whisper, a shimmer, a lullaby made of blue. And as its last words dissolve into silence, only one remains. A soft benediction from the oldest memory on Earth. Good night.